Assalamualaikum and good morning to our lecturer. My name is Ni Afif bin Ni Abdul Majid. Today our group will present about our project assignment for subject Highway Technology and Traffic Management Section 2. The method that we choose for this project is traffic congestion. So the title of our project is Traffic Congestion at Kuching, Sarawak. Before that, for this presentation, we will label each name of group member for each part of slide presentation.
Introduction. Traffic congestion is a condition in transport that is characterized by slower speed, longer trip times, and increased vehicular queuing. Traffic congestion on urban road network has increased substantially since the 1950s, when traffic demand is great enough that the interaction between vehicles slows the speed of the traffic stream. This results in some congestion. In Malaysia, Sarawak is noteworthy for having three different segments of the Pan-Borneo Highway, sandwiched by two segments of the Bruneian Pan-Borneo Highway. Federal Route 1 was constructed in sections containing a total of 92 sections. In general, all other Sarawak federal and state highways are tributaries of Federal Route 1. The highway in Sarawak only its west-focused highway and connects most of Sarawak divisional capitals except for Kapit and Muka. The parts from Miri to Limbang and Lawas are connected by highway networks in Brunei. At the Sarawak-Sabah border at Merapuk, in order to enter Sabah and vice versa, motorists must pass an immigration checkpoint. In Sindumin, the motorway starts at Malaysia Federal Route 1 Sabah.
Assalamualaikum and hi, my name is Kurera. So the next part is about literature review. So traffic congestion is a phenomenon characterized by slower speeds, longer travel times, and increased queuing of vehicles. There are two forms of total traffic congestion according to Department of Transportation, DOT, which the first one is recurrent and the second one is non-recurring. Other than that, there are also have four basic definitions, which the first one is environmental, second is mechanical, and the third one is human. All of these are included in non-recurring, and the last one is infrastructure, which is recurring. This can be shown by ironically 10% of the traffic is triggered by development in attempts to develop infrastructure, because according to DOT, 40% of bottlenecks alone constitute to the cause of traffic congestion. In that of the construction of the flyover at mile 6, 7 and 10 Pen Borneo is intended to save travel time and reduce operating costs for vehicles, particularly during peak hour. In order to work at time when traffic is lighter and roadwork should have less effect, innovative scheduling may be used. Thus, when performing traffic control training, the use of graphics including maps, images, and videos to help overcome traffic congestion. And the last one is the advantages of this flyover construction. It is provides road user with more convenient road trips, which it makes the time of travel will be more shorter across Sarawak, where there are 4 lanes, allowing slower vehicles to be safely overtaken and interchanged. Furthermore, it will increase efficiency that takes less time to drive, lower travel and tolls-free rates.
So for the proposed solution and ideal, according to Lee 2019, this traffic congestion occurred due to the construction of flyovers at Mile 10, 7 and 6. Thus, once the construction is completed, the flyover provides a smooth traffic flow. The solution of the problem are opening the additional lane, which is the existing 2-lane road. At the Mile 6 is widened became a 3-lane road as temporarily measured during the construction stage. Not only that, we are using the information technology for the alternative way such as Waze and Google Map in order to find the shortest route and save the driver time in order to let them arrive their destination even faster. The project objective is to provide a structure that will be suitable in a specific environment and able to sustain the anticipated traffic loading. So as you can see from the picture, this situation at the road when a lot of vehicles are crowded in one time place causes difficulty to move and waste the productive time for the drivers. This location at Mount 10 until 6 in Kuching, Sarawak. There are two peak hours, which is the morning peak 6 a.m. until 11 a.m. and evening peak 4 p.m. until 8:30 p.m. So as you can see, it's because of the drivers who want to go to work in the morning. They are using the road, and also they want to go back to home at the evening peak after they work. The main factor of this problem, the traffic congestion problem, is because there's only one main route to go to Pusat Bandar Kuching. So every driver is using this route in order to go to Pusat Bandar Kuching. The next one is because for the construction activities, the construction flyovers at Mountain 7 and 6 at Pan Borneo, and it also causes a lot of the problem for the drivers who want to go to the Pusat Bandar Kuching. So as the solution for this problem, I suggest to widen the road from 2-lane road is widened to the 3-lane road. Not only that, we also suggest the alternative road by using the communication technology such as Waze or Google Map. By using these two communication technology, driver can reach their destination even faster by using the alternative way.
Next is design procedure. So this procedure show that step of how we solve the solution of traffic congestion in Kuching, Sarawak. Firstly, development of design input. So there are three of it. Initial average traffic in one direction, percentage of commercial vehicle, and average annual traffic growth factor for CV. So secondly, determine information from geometric design, number of lane, terrain condition, and third, select design period based on social consideration. Fourth, calculate the design traffic for the design lane and base years. So calculate the design traffic for the design period, design life in years using following formula. So Najah we present about the calculation. So 6 property of subgrade and 7 properties of paving material.
Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Siti Nunajah Nazia binti Muhammad Jafridin. I am presenting about the data calculation. We are decided to design a road pavement for a 3-lane with average daily traffic of 7,680 vehicles with 25% of commercial vehicles with an unlimited weight more than 1.5 tons. For the step 1, the development of design input for the total 3-lane, it is 23,040 vehicles. The design of pavement based on 7,680 vehicles, which is one direction 24 hours period. If the design based on traffic data from HPU survey, the result based on a 16-hour survey should be multiplied with 1.2. So the related information listed, which is PCV equal to 25% and the lane distribution factor is 0.9 because the existing lane there are 2 lanes in one direction, and the train factor is 1.1 because it is rolling, and this pavement designed for 20 years and annual traffic growth is 7%. For the step 2, to determine the design traffic, which is traffic category, by using SLU1 base year formula. So the formula is ADT multiplied with 365 multiplied with PCV multiplied with LEF multiplied with L multiplied with T, and we got 2.428 million. And for the design traffic over 20 years, it must multiply with TGF, and we got 99.548 million, which is more than 30 million, so the traffic category is T5. The step 3 is to determine the subgrade strength. Because the CBR is more than 30, so the subgrade category is SG4. And to determine the pavement structures, we need to look at the tables. Okay. By using this table, we can determine the pavement structures T5SG4, which is we are using the conventional flexible general base. Okay, so the SG4 we are using because the CBR is more than 30 and the category of traffic is T5 because it is more than 30 million SL. So this is the pavement structures for this project. Thank you.
Next, for the information technology, in order to achieve the efficient or more coded journey in construction at flyover at miles 6, 7 and 10 Pen Borneo, the information technology such as Global Positioning System (GPS), which combines with Geographical Information System (GIS), it helps the user to know the condition and situation of the road. This can indirectly reduce the waste of time, which the road users can manage to arrange their time wisely. And lastly, there are a lot of information technology applications like Apple Map, Waze, Google Map, and others applications, which they can be used to find the shortest route to get to the destination faster than usually, and also at the same time able to avoid passing in crowded areas.
Conclusions. In conclusion, it is perceived that climatic impacts and loading have the strongest relationship to road damage. Weather and road damage can contribute to crashes, which in turn lead to wasted spending. All Malaysian road infrastructure stakeholders should concentrate more focus on factors leading to damage and pursue passive sustainable solutions to prevent them. A more comprehensive cost analysis of maintenance, cure damage reduction will assist stakeholders in justifying such a strategic decision.